All right, so in this video, I'm going to explain part D of the question 9 from the week 4 assignment. Notice that I have part C written in here too. So I have part C and D here. And the reason is because C and D are related. Because part C, you're going to use your result from part C to help explain the answer to part D. So notice that they're asking a very similar thing. So notice it says at most 1. So you want to find the probability of at most 1. And in here, it says if the camp counselor wants to make sure that no more than 1, so they relate because they're pretty much stating the same thing. So, and where this does it seem reasonable to him to randomly assign teenagers to tents, that's a requirement for a binomial distribution, which you're using in this problem, is that they have to have it has to be a random from one trial to the next. So that's what we're talking about. It's saying that if would we want to have a binomial distribution, would it be reasonable? And so the way to answer this is we want to determine if we want to make sure that no more than one teenager, meaning we want a 0% chance. That's the only way that we want this to occur. Do we want to make sure that no more than one teenager? So we want to see what is the probability. We want the probability that no more than one teenager. So we want to make sure that the probability that X, meaning whatever the number of people that are afraid of spiders, the probability that X is greater than 1 is equal to 0. We want to know, is that possible? I mean, is that going to happen if we have a random assignment? Well, we should figure that out based on the probability from part C. So let's say if the probability of part C is 75%, let's just say, the answer to part C, there's a 75% chance that at most one of the suffer from arachnophobia. Then we can determine the probability that X is greater than 1. Well, that would mean that the probability that X is greater than 1, if we had a random assignment, is going to be equal to, since this is at most 1, greater than 1 is going to be 1 minus 0.75, which is 0.25. So, which is not equal to 0. That's no good. So the only way that we would actually be able to say, yes, we do want a random assignment, is if the probability of C is 100%. That would mean that the probability of being okay to do a random assignment would be 0% chance of this occurring, to make sure that no more than one teenager. So hopefully that makes sense. So you should be able to tell that this would be no, pretty sure. If part C is not equal to 100%, and you want to make sure, meaning guaranteed 100% chance, then if this is not 100% for C, then this is going to be no for D. So hopefully you can use this logic here to explain why D is false, or the answer is no, that we do not want to use a random assignment, that we want to make sure that we ask the teenagers, are you afraid of spiders, and then put them in the tent, or whatever we're talking about, a tent. So hopefully this makes sense. It's the idea of making sure, meaning 100% chance, and that then this logic falls in line. So let me know if you have any concerns about this. Part D is a bit of a challenge, but you just kind of have to interpret it and break, break it apart how I mentioned here, and hopefully that makes sense. Let me know if you have any other concerns.